Okay, we are finishing up the course with systems of inequalities and linear programming. So we're going to look at the graph of linear inequalities and systems of linear inequalities, and then you will finish up the course with some linear programming problems. So we've seen already what a linear inequality looks like, and in two variables. So we have two variables here. And I can simply graph this by, notice if I have y is less than x plus 3, I graph the line x plus 3, and anything less than would be a solution. And in fact, you could check points, right, to make sure. Of course, 0, 0 is always a nice one. If x is 0 and y is 0, 0 is less than 3, so that is true. Notice the line is dotted because this is a less than, not a less than or equal to. If it was a less than or equal to, then the line would be solid. And this shows how to actually do these graphs. Replace the inequality symbol with an equal sign, and look if the inequality is less than or greater than, draw a dashed line. Otherwise, less than or equal to, greater than or equal to, the line will be solid. Definitely want to look at a test point on one side of the line, and that's where you will do your shading. So I have 3x plus 4y is greater than or equal to 12. I graph the line 3x plus 4y equals 12. Notice this is a solid line because it's greater than or equal to, and I shaded this region because it's greater than, but notice if I plug in 0, I don't think 0 is greater than, so this doesn't contain the solution, so we would not shade this side, we'd actually shade the other side. If I'm looking at x is greater than -3, once again, it's not greater than or equal to, so a dotted line. I can find a test point over here that is true. Looking at the y, so a horizontal line, y equals 4. This is a solid line, less than or equal to 4. I'm going to check to see if I'm going to shade below, and I plug in a value below. So I picked a point in -2, 5 above, and notice this is false, so it's not a solution, so I know I shade the other side. You can also use systems of linear inequalities, and you're going to see that these are based on where they overlap for solutions. So we still do the same thing with our graphing, and we can see that the less than x plus y less than 4 is all underneath here. The x minus y greater than or equal to 2 is all this area. If I'm getting to the last part of this, where linear programming, sometimes we want to see where they overlap. So that is the last part with applications. These are great finding max or mins. Even if you have constraints, such as you have a company that you can only make so many items, you can get feasible solutions. You want to see what is going to maximize your profit or minimize your cost with these objective functions, and this is the procedure that you will be using to be able to solve these linear programming problems.